Hello everyone. This is homework 1 for exam 1, which covers ratios and proportions and percents. And so homework 1 is ratios and proportions. First concept is what a ratio is, and as you can see, it's just a comparison of two numbers or two quantities with the same units. Some notation: you could read a ratio as A, and then the colon is read as 2, and then B. You could literally write the word 2, A to B, and our preferred notation, fractional notation, A over B. So we're often asked to write a ratio in lowest terms, so you just simply put the first number in the numerator and the second number in the denominator. So 28 over 7. If we want lowest terms, you want to divide by the greatest common factor. In this case, 7. So divide by 7, divide by 7. And that gives us 4 over 1. And since a ratio is a comparison of two quantities or two numbers, we're going to actually leave the one that's in the denominator. So you could express that as a ratio of 4 to 1. So the second example, to set it up, first number in the numerator and second number in the denominator. So 5.2 over 7.38. Now, we can't have decimals mixed with fractions, so we have to somehow get rid of the decimals. And there's two ways to do it. I'll show you both ways. What I like to do, no matter what, is to make sure that the numbers involved have the same place value. So 5.2, 5 and 2/10 is to the nearest tenths place, and 7.38, or 7 and 38 hundredths, is to the nearest hundredths place. So what I'm going to do is add a placeholder, a trailing 0, onto 5.2 to make it 5.20, which could be read as 5 and 20 hundredths, and then leave the 7.38, and now they have the same place value. And then what we could do is we could multiply by an appropriate power of 10 to remove the decimals. In this case, the nearest hundredth, so multiply by 100, numerator and denominator, and we get 520 over 738. And now the decimal is eliminated. We'd still want to reduce the lowest terms, and you don't have to always pick the biggest number. I'm going to go with a 2 because they're both even, so I know they are both divisible by 2. If you want to use your calculator, do the division. 520 divided by 2 is 260. And let me just make sure I don't make a careless mistake here. 738 divided by 2 is 369. And now that's in lowest terms because there's nothing common between those. So that's our final answer. Now, alternatively, you could start with the same situation, 5.2 over 7.38. And again, I like to add the trailing 0 to make the placeholders, or to make the decimal numbers have the same place value. But instead of multiplying by 100 over 100, equivalently what you could do is just move the decimal point. And you have to move the decimal point the same number of places in both numbers. So watch with these little loops. If I move 2 places here and 2 places here, then of course we get the same answer. So if you want to use that little concept, I'm going to divide by 2 again to reduce this to lowest terms. So 260 over 369. It's a little shortcut concept. If you want to use that, you can. We'll show the next example. Again, to begin with, first number in the numerator, 2.6, over second number in the denominator, 20. Again, there's decimals involved, so I want to get rid of them. There's no decimal in the number 20 written. It should be understood it follows the 0. And to make them have the same place value, we'll add a 0 onto the 20 after the decimal point. But see, it's not always that we're multiplying by 100 over 100. The reason why we did that in the last example, because we're to the nearest hundredths place. In this case, we're to the nearest tenths place, so we'll just simply multiply by 10 over 10. And that gives 26 over 200, and then you could reduce that. Again, I'm going to divide by 2, and we get 13 over 100. Okay, those are all comparisons of numbers. You could have comparisons of quantities with the same units. So 4.2, I'm just going to abbreviate and say giga, over 0.63. Again, I'll abbreviate and just say giga. But see, if they have the same units, we can cancel the units. So if we cancel the units, sometimes people will replace them by ones, really not necessary. Not too many people often show that. It's really just comparing the numerical portions. But again, here's a situation where we've got decimals. Largest place value is the hundredths, so let's express 4.2 as 4.20. Recopy 0.63. If you want to do the little movement of the decimals, you could basically just drop the decimals if you want. But I'm going to show literally multiply by 100 and multiply by 100. And we get 420 over 63. And actually, these numbers are both divisible by 3. If we divide 420 by 3, we get 140 over 21. But then we could even go further and now notice that these are divisible by 7. And that gives 20 over 3. Okay. Now here's a trick. If you bought the TI-30X2S calculator as I recommended, the trick for reducing fractions involves using the fraction key, A with the B over C. It's right under the PRB button. And so if I enter the numerator of 420, hit that fraction key, and this little backwards L pops up, indicating the fraction bar. Enter the denominator of 63, and then hit enter. I get an answer. It looks a little bit funny, but it means 6 and 2/3. That means the whole number part is 6, and the fractional part is 2/3. And we should know how to convert. You multiply denominator times the whole number, so 3 times 6 is 18, and add the numerator is 2, 18 and 2 is 20, and we get 20 over 3. Now, a way to change that on the calculator is, if you look above, it's a little bit hard to see here, but if you look in blue, it has this A with the B over C, and arrows going back and forth to a D over C. And I don't know if I can bring that up, but yeah, D over E, you can see that now. And so that'll convert this fraction, this mixed number, into an improper fraction for us. So then if I want to get to the blue part, so if I hit second function first, and then that fraction key again, notice how it's telling me what I'm doing. I'm going back and forth between mixed number and improper fraction, and then just hit enter, and it gives us the 20/3 as we know. Okay, so use your calculator to your advantage, and definitely worth the $10, $12, whatever it cost for that. Okay, next thing is a rate. A rate is a comparison of two quantities with different units, as opposed to the last set of examples. We had the same units, or we were just comparing numbers. Here, we're looking at things with different units. And if we're asked to find a unit rate, we just simply divide. So we're going to express this as 114. You have to keep the units. $114 over 12 quarts. And then we just simply divide. 114 divided by 12, break out your calculator, is 9.5. And so I'm going to express this as $9.50. And then here's what we could do. Division, you could use the word per. So this would be $9.50 per quart. That's the most common way to express the answer. Or, yeah, that's the best way, is to use the word per there in this case. Okay, so another example of a unit rate. This one says a computer's hard drive rotates at 7,200 revolutions per minute. Find the unit rate in revolutions per second. And this one looks a little funny because there's only one number rather than having two numbers. But let's start with the given. We have 7,200 revolutions. I'll just abbreviate that as rev. And remember, per means division, or your fraction bar. So 7,200 revolutions for every 1 minute. And we have to give the answer in revolutions per second. So essentially, minutes need to be transformed into seconds. And it's just a replacement. There's nothing fancy here. It's just what you might call a replacement. We'll leave the 7,200 revolutions. And instead of 1 minute, we want it in seconds. So, common knowledge, of course, there's 60 seconds in 1 minute. And then we do the division. Break out your calculator if you need to. Okay, now there's two ways we could rate this one. We could rate 120 revolutions per second. So leave the fraction bar and it's read as revolutions per second. Or you could say 120 and literally write out the word per, as we did earlier. Revolutions per second. The reason why it was more favorable in the last example, because we were dealing with money, we had the dollar symbol in front of the numerical portion, so it was preferable to explicitly use the word per. Whereas in this particular example, this first answer may be more desirable, but either way is fine. Okay, so we move on to a proportion. And a proportion essentially just equates two ratios. And it's often expressed using what we call an is as is format. The is basically refers to a fraction. The as is your equals, and the is represents the second fraction. So in this expression, it says write the following statement as a proportion. 20 dogs is to 4 cats. That's our first fraction. So 20 dogs over 4 cats. The as means are equals. So is equal to, and then the 30 dogs is to 6 cats, represents the second fraction. So equals 30 dogs over 6 cats. And that's all we're going to do with this for now. But one thing, oops, I'm sorry. You weren't, I didn't have my paper so you could see it as I was writing. So I'll give you a second to catch up. But just to comment on the way that's set up with the units. Notice how the units are aligned in the sense that dogs are in the numerator and cats are in the denominator in this fraction on the left. And on the right-hand side of the equals, the units are lined up the same way. Dogs in the numerator and cats in the denominator. That's going to become very important when we get to solving word problems involving proportions. But first, let's practice solving proportions without word problems. And before we do, we consider this concept: how to determine if a proportion is true or false. We calculate what we call the cross products. So I left this blank because it's important to write it out. If A, B, and C and D are real numbers, we could say A over B equals C over D. And then here's the cross products. You take the denominator of the second, cross over the equals, multiplied by the numerator of the first, and the denominator of the first crossed over the equals, multiplied by the numerator of the second. So D crossed over times A we'll write as A times D. Whenever you take the first cross product, make sure you write down your equals immediately, and then cross over the B times the C, and we'll just literally write it that way, B times C. So that's how we calculate cross products. So if you're asked to determine if a proportion is true or false, like in these examples, you just simply calculate the cross products. So here, 24 crossed over times 8. So we'll take 8 times 24. Okay, I'm going to do it this way. I'm going to say, put the equals, and I'm going to put a little question mark. Is that equal to? Because I don't know yet. Then I'll take the 13 crossed over times the 15. And you might go to your calculator at this point. I'm just going to do so I don't make any careless errors. 8 times 24, 192. Is that equal to 13 times 15, 195. And obviously 192 is not equal to 195. So since that's a false statement, we say the proportion is false. Okay, let's see what happens in the second example. Again, cross products. 5 times 12. Equal to, I don't know yet, 20 times 3. 5 times 12 is 60, and 20 times 3 is 60. Since that's a true statement, so this one was, I'm going to use these little arrows, kind of like a double arrow, which means implies. So that was a false statement. Okay, maybe it'd be consistent up with the little question mark there. But 60 we know is equal to 60. That's a true statement. So therefore we could state that the proportion is true. Okay, so that's how we determine if proportions are true or false. Now the next thing gets us set up for how to solve linear equations by what you might consider the multiplication or division property. When we have an algebraic term such as 7x I chose, that means that the 7 is being multiplied by x. And if we write that out, here's the terminology you need to get used to. The 7 is the coefficient. Okay, that's the number in front of the x, which is the variable. Now a variable could be x, y, z, m, n, p, any letter you want. It just means that it varies. And our job often is to determine, well, what is it? What's its value? And I wrote in this concept to solve equations of the form ax equaling b, assuming a and b are real numbers. We're just going to divide both sides of the equation. Let me get rid of this extra by there. We divide both sides by the coefficient, the number a. So some of these equations you can solve by inspection. Like if I just told you, don't be intimidated by algebra, because algebra is just some simple steps that lead to logical solutions. And if I just told you 4x is 12, and I said, well, what's a number that makes that true? Hopefully everybody would say 3, right? And that would be, of course, because 4 times 3 is 12. But we want an algebraic approach. So I'm going to rewrite this. It's of that form, ax equaling b, and we're just going to divide by the number in front of x. That's its coefficient. But whatever we do to one side, we have to do to the other side. Now, formally, these 4's cancel. We get 1x over 1, or 1x, or just simply x, and we do the division. 12 divided by 4 is 3, as we expected. Similarly here, you might guess, well, 9, and then there's an x here, so 9 times 3 is 27. But what I want you to get used to is the algebra and how to write it out properly. Because when we get to more complicated situations, you need to be able to be proficient at your algebraic manipulations. And one other thing is the fact that the variable does not have to always be on the left. I know students are more comfortable when it is, but it could be on the right-hand side, so you have to be versatile. But you just want to divide by whatever's in front of the x, or in front of the variable. So we're going to rewrite 27 divided by the 9 to get rid of the 9 to solve for x. And again, the 9's cancel. You don't need to show the cancellation. And we get 3 equals x. See, that's the same thing as saying x equals 3. So you don't have to rewrite it that way. 3 equals x is fine. The reason why we need this algebraic manipulation is because it's not always easy. In those examples, it was easy to guess x was 3. Here, 12 times what's 138? I don't know if there's too many people that can come up with that quickly. So we need algebra. So we're going to divide by the coefficient of the variable. What you guys probably say, the letter in front of the number. which is going to divide by 12. Again, the 12s cancel. We get n over 1, or just n. And here you could use your calculator. Excuse me. And we have 138 divided by 12, equaling 11.5. Okay, and then the final example. Now, decimals involved, certainly not anything we could do mentally. So we divide by the coefficient. It's on the variables on the right. That's okay, just leave it there. So 65.1 gets divided by the 0.7. And obviously the 0.7p gets divided by the 0.7. The 0.7s cancel. We just get p on the right, 1p over 1, or just 1p or p. And obviously here, calculator, 65.1 divided by 0.7 is 93. Okay, I'm going to stop the video right there. I usually like to keep the videos at 30 minutes or less. So that's part 1. We'll come back and finish up this homework number 1 with a part 2, and then obviously move on from there.